Good morning. Thanks for being here, and thanks for attending our workshop. Right. A quick round of introduction. So my colleague here is Richard. He's a sales engineer at Solace. My name is Hari. I'm a developer advocate at Solace, and we are going to be talking about event meshes, what is AsyncAPI, and what it brings for EDA. What are we going to be talking about is what is EDA, just a small refresher because I'm pretty sure that most of you guys know what is EDA here. Why should we use EDA? Again, it's a small refresher. What is an event mesh? So this is where it really starts to get interesting. We talk about what is an event mesh, why we want to do an event mesh, what it brings for us. Then we're going to be focusing on the Solace PubSub Plus, Event Plus, which is an event broker and event mesh as one of our offerings. We talk about, we do a small transition to AsyncAPI, which is really up and coming. It's a really interesting thing, and it's really fun for me to talk about it and work with it. And so what does it do for EDA, right? So why should we use AsyncAPI instead of OpenAPI, and what are the alternatives and stuff like that? Then, enough of the theory, we are going to do a small demo, which is going to be really interesting. We are going to be talking about flights and real-time events and stuff like that. So let's get started off then. Our lives are pretty much event-driven, right? So everything we do, everything that that moves around us, we generate an event one way or the other. An event is pretty much just a message that is sent by an app or a person or a device or whatever to signal the occurrence of a change in state or change in a situation, right? We have, as I said before, events all around us, literally. So we could have, in this social media age, where literally you walk around the street, people really go walking around the street, filming themselves or making a post about it. So that's an event. You have logistics and delivery events spread across the world, which have to be processed or which are crucial to be processed in real time. We have business and transaction events, about trading events, about financial transactions, which have to be processed in near real time or really real time. You have shipping information or shipping events or weather forecast events get generated from around the world in, millions and millions of events per day, right? All of this, if they are leveraged in a very effective manner, bring about a lot of value, which is sometimes lost when you don't do that leveraging in the right time or right place. IoT devices and applications. So things used to be really dumb before, but then now with the IoT devices, it's generating a lot of events, and when we can utilize these, we can monetize on those, and we can get advantage of that. Now, since we know that all these events are getting generated, we should be talking about why our architectures, why our applications should be event-driven, right? So we have all these distributed softwares that are being built. Earlier, we had these nice monoliths, EAR, WAR files, JAR files, which used to be in one server or multiple instances of servers, and then, they used to cater to around the world. But now we're talking about distributed applications. We're breaking down these big monoliths into small domain-based services, domain-based entities, and then you can work around with those. With this distribution, we need to have a good coordination and orchestration between these services. IoT devices, as I said before, 20 years before, my fridge used to do one thing. It used to cool stuff, right? That's it. But now, my coffee machine, I can program my coffee machine from my bedroom saying, okay, I'm gonna be there in 5 minutes, make a coffee for me. It does that for me, right? It can tell me where, okay, your coffee filter beans need to be changed up or refreshed. So all of these events, all of this information, all of the state information is coming in terms of events. We can work on those. We should be able to work on those. Earlier, we used to have simple request and response format, right? So you make a request to me, you wait for me till you give me a response. I give you a response. You go about doing your own work. But nowadays, it's, as I said before, the distributed world of services, distributed architectures. We are moving data across the world. We are moving data across hybrid platforms. We're moving data across applications which are working on different languages, different technologies, and it may require that we need a response at some times. It may be that, okay, I don't really care about a response. I'm just sending information to you. I'm throwing it at you and you're done with it. You can do whatever you want. It can be a fire and forget, or it can be something on a command where you tell me, okay, you have to do this. Or I'm just giving you an information, okay, this is an event, something has happened. Now, for this, our architecture needs to be event-driven, and it has to do more than just request response. Talking more about that, right? We are just talking about two applications here, A to B. But what happens if we have a new application, C, which is also interested in our event? How do you orchestrate that? How do you give information to that? How do you expose this information? How do you know whether this information is allowed for that entity, right? So, and this is just one of the many issues that we have. SaaS applications. So we have SaaS platforms, we have REST services which are coming up. As I said before, we might be doing request response now, but then that's not the only way of interaction. We need to do more than just request response, and therein comes why our architecture should be supporting event-driven interactions, like streaming, like kind of fire and forgets and things like that. Now, the ways that you can use an event-driven application or an event platform, right? So we want to use it to orchestrate microservices. We want to make sure that the event flows between different microservices on a nice streamlined manner where you don't have to wait for responses and be blocked doing nothing, because you can simply send it over to an event broker or an event platform. That will take care of publishing it. That will take care of distributing it to all the interested events or the interested applications. You can use it to push events from on-prem applications to cloud applications, and then using an event platform, you can integrate as many cloud applications or cloud platforms that you can want or your business requires. IoT devices, again, you can streamline these events coming from different applications into a cloud event platform. You can send it through any integration. You can send it through to an analytics platform if you want. You can have it to a different data dump or EDL or something. That's completely up to the business, but then it gives you options and ventures for this. You can have different data from service lines. You can orchestrate them. You can curate them. You can bundle them up together, and then you can expose them as services within and outside your enterprise. And it's quite powerful in the sense, you could have a situation where one entity or one business line is working or having some or using some data which nobody else in your enterprise knows about. Why? Because it's all in silos. But when you take it out of that silo, you put it in an event mesh or in an event broker, and you can make an event API product out of it, you generate value from it. It's data lying around us just in one place, it's useless, right? So you want to monetize it somehow. You want to generate value, and that's where you could use an event platform for this activities. Now, I want to talk about EDA, and for that, I want to switch it over to my colleague, Richard, because, yeah, I don't want to talk for the next 50 minutes and bore you to death, right? So he's going to take it up things a bit. So, Richard.
Great. Thanks, Harry. So, okay, we want to be interested in delivering and building EDA. How do we do that? We want our applications and business processes to be more event-driven. We need two main things. We need something called an event mesh, and we need event management. So the event mesh is really the runtime for your EDA, and that's responsible for delivering your events securely and reliably to whoever is interested in receiving them. And it's called a mesh because it's composed of an interconnected network of what we call smart event brokers that allows all your disparate systems deployed across different geos, different clouds, even legacy on-prem systems can all sort of come together and communicate across this mesh. And a lot of you are probably developers and architects, and this really provides you with this kind of abstraction layer, right? So you can easily publish your events. You can easily subscribe to the events that you want to receive. So this really gives you this kind of location independence as well, and allows you to just kind of concentrate on your application logic. And the event mesh will take care of routing these events dynamically to wherever they need to go. So the other important factor for EDA is really around what we call event management. So you're going to also need a good set of tools for event management. So this kind of gives you the ability to design and document your EDA, allows you to just discover events and understand events and how to use them, and kind of provides you with a kind of governance layer as well for ensuring that your different teams across different lines of business are all consistent and follow best practices. But you might be thinking, why use an event mesh? What's the point of adding this extra layer in my infrastructure? Why not just use point-to-point REST APIs? Yeah, well, you could do that to a point, but you'll probably find ultimately as you start to scale, especially if you have a lot of interactions between systems, and particularly if they're going across different geos, that tends to not scale well, and you'll start to get stability and scaling issues. So having this kind of distributed layer in your architecture really gives you these kind of three main things. The ability to connect applications, services and systems across different landscapes and lines of businesses. The ability to dynamically route and filter event data reliably and securely across the mesh. And the ability to push information out in real time to multiple recipients, right? So this really enables your applications to be kind of more loosely coupled, which is always a good thing. And it also gives you these kind of operational benefits as well. So you can get better scalability, reliability, and you can also reduce costs as well. So this event mesh will handle all the traffic across different networks and different locations reliably and consistently. So it uses kind of persistent, secure connections. It can also do things like compression. So it's very efficient at moving data across, WAN links, that kind of thing. It can also give you kind of lower latency within your kind of applications and your systems, because you're not doing long line connections, synchronous connections across different geos and waiting for a response to come back. You'll just connect to your local event broker and deliver a message locally, and then it'll get transferred on for you. So it's kind of fire and forget. And also it gives you this kind of delivery assurance and buffering, right? So you want the event mesh to guarantee delivery of events across your architecture, and you want it to handle kind of buffering. So if you've got a lot of events all being produced very quickly, your applications may not be able to handle that load in sufficient time. So you want the event mesh to buffer those up for you and queue them up, so they'll be delivered to you when you can process them. You can also reduce costs as well. So data would only be forwarded across the mesh based on interest, right? So you don't want to send data across, or you don't want to export data from one cloud region and send it to other cloud regions if it's not needed, right? That's going to cost you data to move that data out. And also, the data is also fanned out locally, right? So if you've got multiple subscribers, multiple recipients within one location, that data only goes across, is only exported once and goes across the network once, and then it's fanned out locally. So yeah, a lot of advantages that you will see as you start to look at using this kind of architecture. So I just want to introduce quickly our Solace PubSub Plus platform. So we call it a platform because it really gives you a complete solution for adopting, deploying and managing your event-driven architectures. And at its core, there's what we call a smart event broker that can be deployed into any environment, any of your different locations that where you have systems. And then those event brokers can be all kind of connected up together to form this mesh. So we can support deploying these event brokers into any public cloud region. Also we can support private cloud regions, so customer-owned private clouds, and even we can support on-prem data centers. As long as there's some kind of Kubernetes platform in place, we can sit on top of that. And then we've also got this kind of management layer. So we've got this is all cloud-based. We've got SaaS-based applications deployed that we manage that help you in building this event mesh and managing this event mesh. So across the top there, we've got these kind of three boxes. There's something called mission control, which is around operational management of your event mesh. This is where you go to deploy event brokers into different locations and connect them up to form this event mesh. We've got something called insights, which is around operational monitoring. So we collect lots of metrics and logs from across your event mesh, and we bring those all together and store them in a central place in the cloud. And then we have dashboards and alerting and things like that that enable you to to easily monitor what's going on. And then we have this event management piece. So we have something called Event Portal. So this is where your architects and developers can sort of collaborate to design your EDA, document your EDA, understand how your events work, what they mean, how to use them, and you can see in there a visualization. We'll show you this in the demo. You can see a visualization of how your applications are communicating using events. So great. Once we've got our event mesh set up, how do we start to use it? How do we connect our applications up to it? So we want a rich capability here. So we want to be able to use any kind of API or protocol of choice. So this kind of shows you the different options that we have in our event mesh. So kind of starting at the top left there in the Solace box, we've got our own APIs that you can use with any kind of language of choice. So if you're building an application, you're writing your own applications, you can build those using our own APIs. We have support for Spring, and then we have support for quite a good range of different open protocols and APIs. So we support MQTT, a protocol out the box. So that's very good for kind of IoT type use cases. AMQP we support as well. We support REST as well out the box, so you can publish an event or a message to Solace via REST. We can also kind of push messages out from Solace via REST to REST consumers using a kind of webhook approach. So it's just synchronous. We just use synchronous REST calls at the edge of the mesh, right? So across the mesh, it's all asynchronous, all event driven, but around the edge, often we need to use REST to integrate out to different applications. Particularly if it's like a cloud-based application or a SaaS-based application, REST is often the easiest option. And then we've got a whole bunch of other connectors that can be used for different kind of technologies, for different cloud services. We work often quite closely with some of the iPaaS vendors, so we have connectors for tools like Boomi and MuleSoft. We can also do WebSockets directly into web-based apps and browsers, so that's something again we'll show you as part of the demo. So yeah, pretty much any way you want to connect to Solace you can do. So that's great. So we've got all these different options, but what we also really need on top of that is really a kind of standard way to define asynchronous event-based interfaces, and that's where AsyncAPI comes in. So I'll switch back to Harry to talk to you a little bit about AsyncAPI.
Thanks. So we have this, right? We built up our event API, we built up our integration, we built up our let's say using the event portal or the whatever we used. We built up our schemas, we built up our events, we built up our applications and designed them and said, okay, this application is going to talk to this event, this application is going to do this, blah blah blah. I have everything in my mind. I have everything in a portal. How do I show it to you? How do I show it to developers? What do I do with it? How do I distribute it, right? When you talk about the same situation or when you come across the same constraint in an REST API world, we still use OpenAPI, right? So we have OpenAPI, which started off as Swagger. You can export it. You have a nice JSON file. You can put it into Postman. You can build up. You can give it to a developer. You can give it to somebody else, at your clients or somebody, and then you can say, okay, this is my API. This is what it requires. This is what it gives you out. Have fun with it. Async APIs are a bit too, asynchronous applications or EDA applications are a bit too complicated to just support or work with OpenAPI. So therein comes Async API. So Async API is an open initiative. It seeks to improve the consideration of the situation of EDA applications. Its goal is to make what OpenAPI did it for REST, but this wants to do it with EDA applications, right? It goes from documentation, code generation, from discovery to event management. It does the whole 9 yards. Now, as I said before, we have an application API, which is simple, right? It sort of abstracts everything that its business logic is based on. It just says, you give me an input, I'll give you out an output. That's it. That's all I do. But async applications are not just as simple as that. We could have a subscriber which is working on some event, right? It's just listening to it and it does what it does best. You have a publisher which throws out an event and says, okay, something has happened, have fun with it, guys. You could have a client which says, I'll publish and I'll subscribe at the same time. So all of this are orchestrated by what we have as a broker, right? So it's in between. How do you go about talking about these interactions just with OpenAPI? That's not really possible. That's not really useful. It's a bit too cumbersome. So OpenAPI does everything for REST-based applications. We have AsyncAPI, which does the same thing for asynchronous applications. And as I said before, OpenAPI describes a REST API very well. You can use it for distribution. You can generate a file. You can send it across to your clients. You can send it across to your parties, interested developers, and then they go on from there. AsyncAPI talks the same thing. What it does is, additionally, it talks about these messages, right? Or the channels. A channel is essentially a location where an event is dropped. So you can say a topic, a queue, whatever. They are just semantics, just naming different names for it. But then it's the same thing. So it describes this topic or this channel receives this event. This application works on this specific event. It publishes it, it subscribes to it, and it has operates on those. Now, I'm sure all of you would have done or built an IKEA furniture or one of those do-it-yourself furniture sometime in your life, right? They give you a small bits of tools that you can work out. They don't simply say, here is Thor's hammer, have fun with it. You just bang it and it'll work out fine. It doesn't work like that. Because every tool has its own use. Every tool has its own benefit. And that's where we do the same thing with OpenAPI and AsyncAPI. So OpenAPIs are really useful for, really work very well for describing REST-based applications, right? So you could have a simple landscape application about the e-commerce landscape. We might have an order management system. We could have a warehouse application or a warehouse service. We could have a product catalog service. We could have a marketing service. And you want to expose these endpoints or expose these resources to your outside world. You can do that with OpenAPI. Now, each of these applications are generating events. For example, an order management service could be generating what is an order placed, an order processed, an order has been shipped, or a warehouse could be saying, okay, my stock is allocated, or my product is available right now. A marketing service could have its own marketing and events and marketing promotion launch events and stuff like that. Now, all of these events, all of these interactions, all of these publishings, they are very well described by AsyncAPI. Now, you have all these events, right? They are all disparate. They are all separated out. They are all different. And then you can combine them together. You can mix and match. You can say, I want to have a order received event or an order processed event or the shipped event. But I also want to use a stock process event or a stock allocated event, and I want to send it to a delivery service provider API. So you could bundle up all these events and then you could make a cohesive entity which generates value for you. Now, how do you say, okay, these are the events that are interested or these are the part of this API product? You can do that with AsyncAPI very well. Yeah. Now, we spoke about AsyncAPI, we talked about what are the benefits of it, etc., etc. But what I'm going to do is I'm going to talk about what an AsyncAPI document looks like. So it starts off with the schemas, right? So it describes the schemas that are involved in that operation. So it could be a publishing or a subscribing, but then you're still looking at the data set, the entity model, simple as that. Then you have a model, and that translates to an order event. So you have a section where you talk about, okay, what are the events that are actually getting processed in this application by this application or on this channel or topic. And that's a third thing, the channel. This section talks about, okay, this service or this topic looks at an order event. And how do you know what an order event consists of? You can look it up in the schema. So these are the three main components. In our demo, what I'm going to do is I'm going to quickly do a sneak peek, and I'm going to show you how an actual async API document extract JSON looks like. Yeah? So I'm going to do that for you in a bit. Now, we are here. So, a quick recap. What is exactly the outputs of why are we using Open API, Async API? It's an open standard. It allows you to share information about all kinds of your applications in a cohesive, in a standard way with perfect fidelity. So it's machine readable. So if you're generating an Async API document on one event broker or one event service, and if you import it into another one, it'll understand it perfectly. There is no tie-in, or there is no lock-in specific to a vendor or an event mesh or Kafka or Solace or MQ or anything on those lines. It's a community-driven model where you say, at Solace, we are working very closely with Async API. They are very nice people to work with. We are telling them about, okay, this is how we envision EDA in the next few years. This is what your new version would be nice if it can address these points, and they're very receptive. It helps us bring an engagement into the whole process. It brings an engagement into a situation where it's not somebody is building up something for you and then you are tied with it, right? So that's kind of nice to work with. There is a lot of increasing adoption in the industry itself. There is a lot of interest in the technology communities. People are very excited to work about it. And it sort of brings us together and fosters innovation. It's a product for technology enthusiasts by good technology enthusiasts. So that's enough of the talk, right? So we want to move away and we want to look at the demo itself. So I'm going to give it over to Richard and look at this interesting demo. So Richard.
Right, okay. So before we get to the demo itself, I'll just go through quickly what the demo does and how it works, and then we'll go into the Solace Cloud console, and we'll show you what we've done to set it up, and then we'll actually go and run the demo itself. So what we're going to be showing is a demo that receives live flight tracking data. It's getting this data from an API called OpenSky. This is a publicly available API you can use to query and get back live flight tracking data. And we're going to be taking that data, and then we're going to be pushing that data out as real-time updates over an event mesh. And then we're going to be receiving those events across the event mesh and displaying them in a web dashboard. So we'll be kind of plotting the aircraft on a Google map, hopefully, if it works. And then just to tell you some of the features that we're using as part of our platform for this demo. So we're setting up a multi-cloud event mesh. We'll be using the PubSub plus message pattern. We'll be dynamically routing events across the mesh. We'll be using topic-based subscriptions to filter, and we'll show that in the demo, how you can filter, dynamically filter to determine what events that are being received. There's some microservice integration here, so we built a couple of microservices to do this API event enablement using Java. We've got a web dashboard that we're going to be displaying the events in. That's built using our JavaScript API and is using a WebSocket connection out to the event mesh. And we'll show you how we've done this in our console and event portal. So this is the kind of this is the architecture that we've got set up for the demo. So we've got a global event mesh set up. We've got a broker, an event broker running in Azure in London. We've got one in AWS in US, and we've got one in Singapore on GCP. So we often have colleagues running this demo who are based in US and Singapore, and in their case they'll be moving data across the mesh. In our case, we're based in London, so we would connect to the local London broker, so we'll be predominantly using the broker in London. But part of the demo, we will show you how we can actually route events across the mesh as well. So we've got these microservices here. We've got this OpenSky feed microservice. This is a Java-based application that we've written that calls the OpenSky API. That returns a consolidated list of flights currently that are over the UK. and we take that and we then fire out individual events for each flight, and we'll be producing those events on a topic which looks like this. So it's a hierarchical description of the event. So in Solace, a topic is really just metadata associated with the message. It's not an endpoint. It's not an endpoint that you're sending messages to. It's just description of the message that you're publishing. So it's kind of different from other middleware technologies like Kafka, where topic represents a kind of a stream of data that's going through Kafka. This is a little bit different, right? So this is just a description of the message. So this is what we use to enable us to dynamically route information across the mesh. And this topic can be generated completely dynamically. So we've got these parts at the end with source and flight code. They're in these curly brackets, which mean that data is going to be actually populated dynamically when we produce the event. So in our case, the source is going to be the UK. We're going to be producing events from the UK. And the flight code will be whatever the flight code is for that aircraft, right? So that information will be populated in the event at runtime when the event is published. So on the subscription side, those events will be routed across the event mesh if needed, and we'll attach a web-based dashboard to the event mesh, which will receive those events. And in the dashboard, you'll be able to subscribe to the topics. We can subscribe to a very specific topic, or we can subscribe to a wide range of topics using what we call wildcards. So we'll show this again when we run the demo. But here's some examples here. So we're using stars here. So this first subscription would receive all events from any source for any aircraft, right? But if you wanted to narrow that down, and we only wanted to receive flights for BA, we only want to receive events for BA flights. If we used BA star at the end, that would only match all flights that begin with BA, right? So we'd only be receiving events for British Airways flights. We've also got another microservice here that we're going to use that performs an airline code lookup service, right? So this is again an open API. It's hosted by Amadeus. We've got a microservice that will look up, given an airline code, it will look up the airline code, get back a description, and we're going to publish that description out on the event mesh. And you'll also be able to take part in this if you use your mobile phones. There's a QR code on the display when we run it. You'll be able to also receive these airline code lookups on your phone as well. So those events will be pushed out via the event mesh to anyone who's connected, right? So we'll hopefully show that in the demo as well. So what we're kind of really doing here with these kind of microservices, we're effectively event enabling an existing API, right? So this is something you find you might want to do as you start to move into EDA. You may have existing APIs that you want to be more event enabled. Often you're interfacing to pre-built applications or SaaS-based applications that aren't event enabled themselves. So you can build something like this, a little microservice that will query the API and then push out events, and then you're able to make more use of those events and push them out to multiple subscribers, right? So this gives you much better scalability because we could have hundreds or even thousands of dashboards globally, all receiving the same events, right? So this architecture would scale. Whereas if you tried doing that with dashboards that went directly to the API itself and queried the API, you would soon hit some kind of rate limit on that API, right? You wouldn't be able to have hundreds or thousands of applications all querying that API at the same time, right? You're going to get blocked. Okay, I will now try and switch over to and start showing you some real stuff. Okay, so
it's not coming through.
It's not coming through.
No,
okay.
I think you need to go over to the presentation and exit it. To end show, and then you come back to and then it's there now. It's there.
Okay.
Okay.
Right. So I've just logged into the Solace console. So as we were talking on the slides, there are kind of three areas here: mission control, which is where you can go and build an event mesh. Event portal, which enables you to kind of design your architecture and document your architecture, and insights is all around monitoring. So I'll try and show you some of these as we go through. So the first thing you'll want to do is deploy an event broker, right? So we have got some already set up that we're going to use for this demonstration. So if I search for flight, I can see I've got 3 event broker services already running. One in Azure London, one in AWS Singapore, one in GCP Singapore, AWS US. But just to show you quickly how easy it is to create and deploy these services, I'll just start to create a new service and show you how that works. So you just click Create Service, you'd give it some kind of name, whatever name you want. There's 2 basic service types. There's a developer instance, which is just a singleton broker that you could use for development purposes. And then we've got what we call enterprise brokers. This is basically an HA cluster. That's all deployed for you automatically, so it's set up across multiple availability zones for resiliency, and we replicate state across those nodes, so we kind of support this kind of guaranteed assurance of delivery of events. You can choose from different size options, what we call scaling tiers. So depending on your requirements, you can just deploy a small broker. The smallest one is a 250 connection broker. So that supports up to 250 concurrent client connections. You can go all the way up to 100,000 concurrent connections, right? So if you've got some kind of IoT type use cases, you've got a lot of devices all connecting in using MQTT, for example, you might want to have a much larger broker. So I choose the broker size I want, and I just choose where I want to deploy to. So you can deploy to any kind of public cloud region. These are all pre-configured. You can also deploy to a private cloud region. So there's a small agent that needs to be installed into a private cloud region. So if it's a customer-owned cloud, or if it's a customer on-premise database, customer on-premise data center, then this small agent needs to be pre-installed. That's something that we would do for you, and then it's will be enabled through its console, and it would appear as a private cloud option. So I would just select, if I want to go to AWS, and then I just go and select the actual AWS region I want, and then I'd click Create Service. That would go away then and start building that service, and it would start up. That would take about sort of 5 or 10 minutes, and then it would be available to use. So once you've deployed your services, what you'll then want to do is then potentially, you may just use it as a standalone service, or you may want to connect it up to other services and form an event mesh. So you would you'd build the event mesh in the mesh manager. Again, it's quite an easy operation. You just create a new mesh, give it a name. Then you'd start to add services into that mesh. You'd choose the services you want to connect up together, and then you'd click Create Event Mesh, and it would go away and internally create all those links between those nodes to form the event mesh for you. Again, that would just take a few minutes to set up, but we have already one set up for this demo. We have a flight tracker event mesh set up already. So just to show you that quickly. So here we can see we've got the three services deployed into the different regions. We've got these these links in green that are already set up and connected. We can see some status information here about the kind of health of the mesh. We can see, all links are up. We can also see some latency information here about communication across the mesh, which can be useful. So, right, once we've done that, we set that all up. What we then want to do is then go and start to build our application, start to build our EDA architecture. And we do that in Event Portal. So we'd go into the designer part of Event Portal. And here, this is categorized by what we call application domain. Here we have a lot of application domains pre-set up for different kind of demos that we do. But in a typical organization, this may be a line of business or sort of project area, that kind of thing. So you can have some kind of separation in your organization. So if I go to the one that we've got set up for this flight tracker demonstration. So here we've got a model, a kind of visualization of our architecture. So this shows us the applications or the different systems that we have and how they're interacting together through events. So the larger icons represent applications and the smaller icons represent events. So we've got 3 applications here. We've got the 2 microservices and we've got the flight tracker dashboard. So this is the Open Sky Feed microservice, which is producing, we can see by the arrows which direction the events are going. This is producing an event. This is producing or publishing the flight tracker plane update event. If we just go and have a quick look at that event. So when you build or when you design an event in the event portal, you would give it the topic address that you're going to be using. Right, so we saw that in the slides, so that we'll be publishing events onto this topic. And these parts of the topic will be filled out dynamically as they're published. So here we can fully document the event. We've got descriptions. We've got full kind of versioning capability in here as well. You can also go and see that the schema associated with this event. So this is a JSON schema. So this represents what the actual payload information of the event looks like. So this is the flight tracker update event. So in here we've got a number of fields. We've got one called hex, which is each aircraft has a unique hex code. So that would be the unique hex code for the aircraft. This would be the flight code. And then we've got telemetry information about its current position, its altitude, track and speed. So that's the information that will be contained within the flight tracker update event. We can also see here which applications are using this event, which applications are subscribing, which applications are publishing. So once we've built all our events, we've got a few other events here as well that are being used. One is like a heart beating event that indicates that the microservice is up and running. And we've also got a start event. So the start event will be published by the flight tracker app dashboard. So when we run the dashboard, we'll click a button which will produce this event, which will actually kick this microservice off in to start polling the API and then start producing the events. We've also got this airline code lookup service, so that also uses various events to perform the airline code lookup request and then publish a result back out. So that's what we'll be also using in the demo as well. So once we've built our events, once we've built our schemas, we've built our applications in this designer, what we then want to do is obviously we want to then start going and building the applications themselves. So we would then use, this is where we start to use the AsyncAPI specification. So we would go to each application. We can download an AsyncAPI file. I can just click on download AsyncAPI file. I can download that as a JSON schema. That will download the API specification for this application. I can then go and take that specification, run some kind of code generator on it, depending on what language you want to build this application in. That'll build us a project where we can start to actually build that application itself. So I can show you here, this is the API, this is AsyncAPI specification that we just downloaded. I'll throw that into Visual Studio and Harry can kind of quickly walk you through what that looks like.
So this is what I was talking about earlier, right? So we have a service, and you can generate an open API, async API specification out of it. I want to sort of zoom in a little bit so that you can see it better, right? So these are the 3 components of the file itself that we were talking about. So we have a schema which sort of says, okay, what kind of a model that we are actually going to be throwing around, we are going to be playing around with. Then secondly, we have the messages actually, or the events itself. So which says, okay, what is the event that is getting produced out of these schemas? And then finally, we come to the channels, which is the topic description itself. So if you look at this, it says components, messages, and flight tracker, plane update, source, flight code. So this is the name of the topic or the channel, and it subscribes to this event, or this one, or this channel, it subscribes to this event and stuff like that. So it sort of builds up the whole interaction or the whole integration within the EDA application itself, and it shows out. You can use this to generate code now, and which we'll be doing next. So while Richard talks about how to do that, I have a quick question. So how many of you know anything about Spring Boot Cloud Stream? Has anybody used it? Do you know what it is? Oh, you do. Wonderful. Perfect. Can you tell us something about it?
We build most of our APIs currently in Spring Boot.
Okay. Specifically Spring Boot Cloud Stream. Have you heard of that library from Spring Boot?
Not currently used it myself, but I've heard other people talk about it.
Okay.
They use it for streaming.
Okay, so just a quick recap, right? So Spring Boot Cloud Stream, it's a library from Spring Boot. What it does is it gives you a very nice abstraction layer between your business logic and your broker, right? So you can be on Solace, you can be on Kafka, you can be on RabbitMQ, whatever. You just need to specify your connection details, and that's pretty much it. So it's all broker agnostic. It makes it very, very encapsulated and nice code, clean code, where you're not really tied into a specific broker. And that's what is the generator that we're going to be using for generating our AsyncAPI document itself, or we're generating for the AsyncAPI code itself. Want to show up?
Okay. So to generate the code, we would run a command. Let me first show you what the command looks like.
Ooh, yeah.
Let's open that with. So there's a command called AG, which I think is AsyncAPI generator.
AsyncAPI generator itself. Yeah, it's a CLI tool.
Yeah. So we would run this command and we'd give it the AsyncAPI specification. We would choose what kind of language we want to build our application in. So in this case, we've chosen Java, so this will build us a Java application. We'd also give it the connectivity details for the Solace broker that we want to connect to send and receive these events. So we just run this, and then that would generate us a Java application. We're probably running out of time to do this, but. Don't know if you can see this. So if I just run that script, that would go away and start to build us a Java application, which we should start to see appearing here in a second.
So what it does is we have a bunch of generators, or we have a bunch of templates that we can use. Yeah? So if you want to use Spring Boot Cloud Stream, you could use that specific template. If you want to use a simple Spring Boot, or if you want to go with native Java, if you are a Node.js fan, you can do one of those templates. If you are old school, you can still do Python and Paho. That's all there. If you are not happy with any of these generators, you can go and write your own generator as well, your own template as well. That works out perfectly fine. So it will be really up to what you want to do about it. And it's quite extensible. It's quite open source. So yeah, there's a lot of support for it.
So that would build us a Java project, and then we'd take that and we'd start to add our application code. So in the interest of time, what we'll do is just move on to the demo itself finally. So this is the flight tracker dashboard that we're going to be using. I can connect to one of the brokers in the mesh. So here I can sort of toggle through which one I want to connect to. We've got 3 set up in this event mesh. As we're in London, we should connect to our local one. So we're connecting to London. Click connect and subscribe. So if you look here, we're going to currently subscribe to flight update events with wildcards. So we're going to be receiving flights from all sources for all flight codes. When we click start here, this is going to send that start event to the microservice, which will then start polling and producing events. Right. So we can see events coming in. Each event is kind of printed here. Obviously you can't see them, it's so fast, but we'll probably get up to around 2,000-3,000 events per second as this starts to get going. We've currently got around 200 planes. So this is showing you basically all the current flights currently over the UK. I can click on a flight, select a flight. I can see some details about the selected flight here, so I can kind of see it. This is its unique hex code for the aircraft. This is the flight code, its current speed, heading, etc. Obviously you can see these this information is updating in real time. Every time an event comes in, its position is updated, and its position on the graph is plotted and updated. So we can also then now perform these airline code lookups. So if anybody wants to scan that QR code, you should get events coming onto your phone as well.
Let's say I took this, right?
Can you get it from there? It's too far.
Oh, I can come over and show you, to be honest. If he just makes this magic, I can come and show it to you how it looks like.
Does that help?
You can walk around. Tap on. So, can you click on one of those airline lookups? So it has nothing, right, at this moment. So it's all clean, you haven't done anything. So when Richard clicks on that airline code, you see that EasyJet. And you see another United Airlines. If you just see over there, you have a United Airlines, and that was just generated. Okay, and then you do an airline lookup. You have, okay, it's pending.
Some of them don't. Some strange ones don't always work.
Okay, let me know. That's fine. See, it's all in real time. It's nice, right? It's fun to work with.
So if you did manage to do that, yeah, you should be getting events onto your phone. And if you notice, you'll actually be connected randomly to one of the nodes in the mesh. At the top, you'll see which one you're connected to. Some of you could be connected to London, some to US, some even to Asia.
So if you see right now, for me, I'm connected to the US East Coast zone, or the US East Coast broker. So what that essentially means is, every time Richard was clicking on one of the airline lookup codes, that event was getting sent across from the London event broker seamlessly to the US event broker, and I was looking at it automatically. So we don't really need to do any kind of automatic pre-configuration or anything on those lines. So you just set up the mesh, the event gets transferred out seamlessly once, and it can fan out to any number of downstream applications that you can think of, right? So it's just good use of network.
And also to show you the topic filtering, right? So let's, if we do BA star here, resubscribe. Right, so now we're only receiving events that match that filter. So we're only receiving events for BA flights. So the flights that we're seeing now, they'll all be BA related flights.
What's a main benefit of this approach is, you could essentially have an application which is interested in something that's specific to, say, Singapore or the Eastern Asian market or something on those lines. Now, even if that event is generated in Europe or in America, based upon its subscription, you can be as fine-grained as you want. You can transfer only those events and not the whole set of stream across the network. So if you are interested, you get that event. That's it. So
that's it, I think. Any questions before we go?
So what can we? What we did was we sort of went over the whole EDA concepts. We sort of looked at what is how we can achieve it from our own product. What's next? You can come and visit us as a booth. We are at the end of the hall in the partner village. If you want to know more about technology, more about our product, you can look at join our community over there. We have a lot of data about EDA. We have a lot of publications about how to work with our products. You can talk to experts, EDA experts. You can use all those resources over there. If you want to know how to work with Solace, what we can do, maybe on a low-level code development and stuff like that, you can use the code labs, right? So we have a bunch of code labs about how to work with Boomi, MuleSoft, different Spring APIs, or different programming languages and stuff like that. And that sort of finishes up. So, can we answer any questions that you might have?
Just on the great
Thank you.
demo as well. on the subscription
Yeah.
side, so when you subscribe, do you only get new information from when you subscribe, or can you catch up?
So we do have message queues within the product as well. So typically, each consumer would create its own message queue. So and you would attach your subscription to the queue. So that would attract any topics, any events into your queue, and they'll sit in your queue, and then you can go and read them off your queue at your leisure. So if you're down for a while,
Right.
and they'll be stored there persistently for you, so you're not going to lose them, but
Okay.
you can just read them,
Okay.
and process them as you need. Yeah.
Okay. That's good.
Usually when we talk about EDA, right, so it's more about real-time interactions. So you do definitely have situations or use cases where you want to process back events and sort of generate history and stuff like that, but those are really rare use cases, or quite less in the number, right? You really want to process events within as soon as possible, or within a very limited time frame, after which it's redundant, or it starts losing value automatically.
That then means then that for certain business transactions you wouldn't rely on this. This is more for you would say more IoT, right? If you miss it, no problem, just catch the next one.
No, within Solace you can definitely achieve both. It's just that that is of course a price associated with everything. So you have to maintain persistence. You have to maintain persistence for a certain longer duration. So of course there is a cost associated with it. So yeah, but then it's definitely possible, and we always do process these events anyways.
Yeah, so you can definitely use this for business transactions. That's a lot of our customers are using it for their business processes. And
Because I think that's one of the things you see is when people start subscribing, consuming events, and then you don't realise that actually that event is critical for this next piece of
Definitely.
processing.
yeah.
That's
So
definitely
we will
true.
guarantee delivery of those events, and we'll replicate the state. We can also deploy a broker in a DR region as well. So even if you lose a whole site, we can replicate scape to another region. So so that's one of our kind of core use cases for those kind of mission critical applications.
Okay.
Even though we do support IoT as well, but most of our customers are using it for kind of more business transactional integration, that kind of thing.
Yeah.
When you create the broker in the web interface,
Mhm.
the sizing was based on number of clients. I'm just wondering why it's number of clients, not number of messages.
That's the kind of the easiest thing that we chose to define the tier. There's more to it than just the number of clients that it can support. There are other limits as well. So throughput is another aspect to it. So the larger brokers will also be able to support more throughput. So we do need to look at the whole requirement to see which broker you should use, but that's just the main metric that we chose to use on the display, really, more than anything.
And also, even when you start off with building an application, or when you start off with building a domain, it's you can identify to a certain extent. You can say tangibly that okay, I'm going to have like 100 consumers or 100 applications connected to my broker, right? But it's very difficult to quantify. Okay, how many exactly events are going to be processed or generated per second? Believe me, in my previous companies and previous projects, we try to do that. It goes off the scale wildly. Yeah. As soon as we scale up, we sort of look at hundreds of thousands of events. We sort of didn't account for it coming in, and we are seeing those that performance issues and stuff like that.